How are you all? I hope you all are doing well. We have started lecture series on CSIR NET SET Gate and other competitive exam. Within that, I started to explaining previous year question from linear algebra and other subject too. So in my today's lecture, I'm going to explain to you all one of the question from linear algebra previous year question paper. Now let's get started our today's example. I'm going to explain to you all first of all question, then we go for complete detailed understanding of a solution. So as question it is from the paper third, that means multiple correct answers. So we have to think about all the options. Here we have question, a matrix which is given A, which is a 5, 9, 8 entries are here. 1, 8, 2, 9, 1, 0, okay, which is a 3 by 3 matrix and which satisfies here the following 4 properties. Okay, so we have to figure it out which one of the property will be satisfied by this matrix. Okay, so here we can see our first option. It says that A is invertible and inverse has all integer entries. Second, determinant of A is bounded. Third, determinant of A divisible by 13. Fourth, determinant of A has at least 2 prime divisor. Okay, if we can see this matrix here, entries look quite easier, the options are looking very easier, but when we get their determinant or the number which is coming from there, it is quite difficult to operate these numbers. Okay, so now let's get started our today's solution. We'll see how the solution it look like, and I'm going to explain to you all inverse invertible matrix and prime divisor and everything here. Okay, now let's get started our solution for today's example. In our solution, let's check first option whether it is correct or not. So first option it says that A is invertible. So invertible means a matrix which determinant non-zero, or we also call it as the non-singular matrix. Okay, don't get confused. Invertible and non-singular both are same, having same meaning. Okay, invertible means matrix which determinant non-zero. Okay, now let's check whether it's a determinant non-zero or non-zero. Okay, so I hope you all can find that determinant easily. I do not have to solve this determinant, okay, because it's a time taking, so I'm not going to solve this one. Okay, so you have to go for finding determinant. You will get the minus 4 1 6, which is the determinant of our 3 by 3 matrix. Okay, minus 4 1 6 is a determinant of our matrix. Okay, and you all can see here our matrix which is a determinant is a non-zero, that means which is a invertible. So our first part, A is invertible, okay, which is a true here. A is invertible, which is a true. But the second part here, inverse has all integer entries. Okay, so here for finding inverse, we use plenty of the way to finding the inverse of our matrix. Okay, so within that I feel that we have to use a minor cofactor method. Okay, so what minor cofactor and adjoint method it says that we have to find out first of all adjoint, and then we have to multiply the 1 upon determinant of A to either matrix, then we get the inverse of our given matrix. Okay, as it is a 3 by 3 matrix, so it will be little bit time taking, and we know that as we have minus 416 is a determinant, so for finding the determinant inverse of our matrix, we use A inverse, which is equal to 1 upon determinant of A into adjoint of A. Okay, 1 upon determinant of A into adjoint of A. So as we can see, we have denominator 1 upon minus 416. Okay, so that means the denominator is a much bigger here as compared to the entries of our matrix. So whenever we get the like minor cofactor and thereafter adjoint, okay, so the entries always which goes to smaller than 416 and bigger than minus 416. Okay, so if entries are smaller than 416, surely our answer it will come something like 1 upon something, 1 upon something. But we can see here 1 upon something number which does not belongs to integer. 1 upon something which does not belongs to integer. Okay, so that number it not goes to the integer. But in our first option, second part it is given inverse has all integer entries. Okay, it is not possible here because determinant is much bigger. As just observation, you can answer this question. So if you wanted to find out the inverse, you may go for like this. First of all, find out the cofactor, okay, which is a minus 1 raised to I plus j into m ij, which is a minor of ij, okay. So you have to take minus 1 raised to ij. So aij, for finding aij, minus 1 raised to I plus j into mij. Okay. Find out a minor for every element 5, 9, 8, 1, 8, 2, 9, 1, 0, and then take take its adjoint. Okay. So what we do for adjoint, we convert rows into column and column into rows like a transpose. So once you get the adjoint, multiply 1 upon determinant of A to our adjoint. So you will get the entries from our inverse of matrix. So as we have determined denominator 416 as a determinant of A, which is a quite bigger number, so obviously we'll get the entries there in adjoint of A. So we'll get the adjoint of A like a 3 by 3 matrix, first second third, first second third, and first second third. So at least we'll get the one smaller number here in our matrix, which is a smaller than 416. When we divide this number by 416, we'll get the number which is like 1 upon something number, which not there in a integer. Okay. So our option first part, it is a true, but the second part, inverse, has all integer entries, which is a wrong. Okay. Now option number B, what B say that a determinant of A is a odd. Okay. So here we can see determinant of A, we got the minus 416. Okay. And 416 last number is a 6, so it is not odd. Okay. I hope you all knowing that odd number, even number, prime number, composite number. Okay. Okay, so 416 can be divisible by 2, so it is a not odd number, it is an even number. So our second option number B, determinant of A is odd, which is also wrong. Okay, because it is not odd, it is even. Second, determinant of A is divisible by 13. Okay, so here we can see minus 416 divided by 13. So we have to check whether it is divisible by 13 or not. Okay, so obviously it is divisible by 13. If you divide these two numbers, you will get the 32. Okay, so it is obviously divisible. So option number C, which is correct. Now option number D, which says that determinant of A has at least 2 prime divisor. Okay, determinant of A has at least 2 prime divisor. Now try to factorize 416 into the different part. Okay, so here we can see here we have to factorize 416, and we have to show that the factor which coming from our 416, there at least we get the 2 prime number there. Okay, so here we can see 13 multiplied by 32, 13 multiplied by 32, which is a both multiplication, we get the 416. Okay, so 13 multiplied by 32, we can write 13 multiplied by 16 multiplied by 2, again 13 multiplied by 8 multiplied by 2 multiplied by 2. Okay, 8 to the 16. Okay, again you may write for 2 multiplied by 2 multiplied by 2. Okay, so you got the two numbers here. Okay, 13 and 2. Okay, which are the at least 2 prime divisor. Okay, so what is meant by prime divisor, prime number? Okay, the number which is divisible by 1 and itself, we call it as the prime number, and exact opposite of it, composite number. So we can write that number in the multiplication of two numbers, so we call it as the composite number. So you need to be very careful about prime number, composite number, odd number, even number, this type of the definitions. Okay, so here we can see here our matrix, our determinant can be written as at least minimum. Okay, at least minimum to multiplication of a two prime number. Okay, prime divisor. Okay, so we write it is the multiplication of a two prime number. So obviously 13 can divide 416 and 2 also can divide 416. Okay, so it is easier to divide the two prime numbers. Here it has at least two prime number. Okay, so here option number D, which is also true. Okay, C and D, which is a true, and A and B, which option is a wrong. Okay, so here we can see I solved this answer here. I got the determinant minus 416 here. So matrix is invertible, but as I found here the adjoint of a matrix, I got the entry -2, 8, -46, 18, -72, -2, -71, 76, 31. Okay, so these are the entries from adjoint of A, so which divisible by -416. Okay, so if we divide -2 by 4, -416, we get the 2 by 416. Okay, and we can see it here, our entries which does not belongs to the integer, so our inverse entry not there in an integer. Okay, so option B is wrong. So here we can see options C and D, I solved it here. So if you want the complete solution, you may refer it for your understanding. So these are the 4 options from our question. It is quite easy to solve this question. Okay, nothing is challenging here, simple just calculation part is there. I hope you all have understood my today's lecture completely based on just basic concept from matrix. Okay, so we have to check inverse of matrix, is it invertible or not. So they're divisible by 13 and 2 prime divisor. Okay, we have to check this. So I hope you all have understood my today's lecture. So thank you everyone, thank you for my today's lecture.